Okay, gentlemen, today we're looking at 8.2, day 1, perimeter and area of composite figures. Really all we're doing is looking at figures that are made up of more than two or more shapes. Okay, so the first thing is, in terms of learning goals, is I can recognize a composite figure. All right, so if you look down below, just right there, obviously that's a composite figure. We have a rectangle and a triangle, so it's a composite figure. Kind of like in elementary school where you learned about compound words, right? Two or more words together, somewhat, is the combination of some and what. So compound is just two or more figures in this case. I can determine the total area of a composite figure, and I can determine the perimeter of a composite figure. So we're going to look at that now. What you may find a little bit difficult is memorizing some of the formulas you haven't used in a while, and that's what I'm going to go through here. I may not take you through every single question, but I will lead you to be able to figure the rest of the answer out on your own. Okay, so I've gone ahead and labeled some of this for you to help you out. So for all questions, round your answers to the nearest tenth of a unit when necessary. When it's the tenth of a unit, you should hopefully remember that a tenth means one decimal place, right? So I'll write that in here for you just to remind you of that. And that's right there. So one decimal place. Okay, that's what that means. All right. Looking at the first question, find the length of each indicated side. Okay, find that length of each indicated side. So in this case, we're looking for the side length x. Okay, now if I'm looking for, I showed you the two shapes here. If I'm looking for x, let me highlight that for you. I'm looking for x. What I want to do is use the area of a triangle, right? Or sorry, the Pythagorean theorem. We know length times width will get us area. I think I jumped ahead here with length times width. We actually want to find the length of x. So what I'm going to do is we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. And we're given x, right? So x is the hypotenuse of that triangle. If you look at this triangle here, x is the hypotenuse, right? We have 2 by 2 by x. So we have 2 squared plus 2 squared equal, in this case, x squared. Okay, and that's obviously 4 plus 4 equal x squared. 4 plus 4 is 8. And then we're going to square root that. What you could do, you can leave your answer as an exact answer, and that just means the square root of 8 is x. If you really like, you can use your calculator and say, okay, what's the square root of 8? 2.828. So we're going to say 2.8. We're going to round it. Okay, 2.8 equal x. And I'm going to put a dot above the equal sign because it's approximate. In fact, I'm going to back this up a smidgen. I'm going to back that up just a little bit because we're going to write the units of measurement there. So we're going to say 2.8 centimeters. And the little dot above the equal sign again just means approximate. All right, here it says we're going to find the indicated. I'm going to erase this here because we're not finding the area. If I want to find the length of x and y in this next example, let me just erase this for a second. If I want to find the length of x and y, I'm going to use the Pythagorean theorem. So again, a squared plus b squared, a squared plus b squared equals c squared. And if I want to look at this triangle right here, that I'll highlight this triangle right here. Maybe I should reduce that a little bit. All right, here we go. So if I want to find the length, if I want to find the area of, the side length x of that triangle, I know the base is 26 and the height is 50. So when I'm using the Pythagorean theorem, I'm going to write 25 or 26, sorry, 26 and 50. 26 squared plus 50 squared equal c squared, or in this case, we know it's x squared. And then I'll use my calculator. Now basically, if I want to find x, you know that really we're going to square root whatever this answer is, 26 squared plus 50 squared. And if you have your calculator handy, you can do that a lot easier. So we're going to say the square root of 26 squared plus 50 squared. And we get 56.4. Oops. Let's try that again. 26 squared plus 50 squared. 56.3, 56.4, sorry, for rounding. So 56.4 centimeters equal x approximately. Okay, and then y, we're going to use the Pythagorean theorem again. We know that this length is also 50, right? And we want to look at this base here. Well, what is the base of that? Well, if we look over here, we have this, I'll change the color here, sorry. We have this hash mark that's given to us, and that hash mark is also given to us over here. And if you're given that hash mark twice, we know that that's also 26 centimeters. So if that's 26 and that's 50, then y has to have the exact same value because they're really the exact same triangle, or they're congruent triangles. They both have a base of 26 and a height of 50. So then y is approximately 56.4 centimeters as well. In this case, we're finding the length of x. Okay, we have, again, it says find the length of each indicated side. So we're looking for y and x. Here we're given, I'll highlight what we're looking at. Here we're given the entire height of this shape is 13.5. Okay, we're looking for x, and we're also looking for y. All right, how would I find out x? That seems to be the simplest one if you take a look at this, because we have 5.1 is the length of this line here. We have 6.6 the length of that line, and 5.4 the length of that line, and those three together are the same length as x. So I'm going to say here x is equal to 6.6 plus 5.1 plus 5.4. Those three, 6.6, 5.1, and 5.4 added together should be our answer. (17.1) centimeters. So x equals 17.1 centimeters. Okay. If we know the total height of our shape is 13.5 centimeters, then y is going to equal, again, the whole height right here is 13.5. We know this height right here is 6.3. So the remaining part right here is y. So really, y is equal to 13.5 minus 6.3. 13.5 minus 6.3. 13. This gets finicky if you don't do it properly. 7.2, y equals 7.2 centimeters. You notice the units of measurement, I only put them in at the end, right? Okay, calculate the area of each shape. So here, I have each composite figure around to the nearest square unit if necessary. So we're just going to separate these, and I want to separate these for you. What you can do here is you can realize you can draw a dotted line here and a dotted line there if you like, and you can count this as 1, 2, and 3. That's one option. Another option, oh, that's not what I wanted to do. Another option is to erase that, sorry. Another option is to draw your dotted line here and pretend that the entire shape is one giant rectangle and subtract that area if you're calculating the area of that shape. Those are your two options. Okay, so see what works best for you, and that's your hint for that. And for this, you're going to obviously find the area of a rectangle, and then you're going to find the area of the triangle, and it's telling you the height is 6 meters, okay, of that triangle. So you're going to work on that on your own, and we'll work on that, and then I'll take that up with you in class next day. Good luck.